Alright, what are the first three hexagonal numbers? Well, thank you very much, book. They show us the dots, so obviously it's 1, 6, and then this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we're going to have a table that starts at 1, 2, 3. We have 1, 6, and 15. Great. What are the next two? I don't really want to keep drawing this, right? It'd be crazy big. So what's my difference here? What's my difference here? It is... it'd be really nice to have another number to figure out the next height, just to double check that this is quadratic. But you notice that this is 4, so I'm willing to bet that 9 plus 4 is going to be 13. So 15 plus 13 is 28. So that's going to be my fourth figure. And then my fifth figure, as I continue to add 4, is going to be 17 larger, which is going to be a grand total of 45. Alright, so that begs the question. Now this is the hardest problem. This is an extension problem. If you don't get it, I totally understand. However, here we go. Well, there are two ways that we can try to do this. But I think the easiest way is to say this. We know, and if you don't get it, don't worry about it. This is an extension. We're going to say y is equal to ax plus by, or bx plus c. That's x squared. And I know my c value is going to be at 0. So if I'm following this pattern, so that's going to be 0, right? Okay. So I know my y-intercept is 0, so my c value is 0. So I can safely assume that ax squared plus bx plus 0 is going to be my equation. Now, what you don't know, and what we did allude to today, is that this second difference is a key component into your equation. Actually, your a value is equal to your second difference divided by 2. So I know my a value is going to be 2, which we have 2x squared plus bx plus 0. And so now it's a matter of plugging in a point. So let's say we have, 0 comma 0 is not going to help me find b. Let's plug in 1. So I know that 1, because I'm plugging in this point, y is 1, is equal to 2 times 1 squared plus something times 1. Well, 1 squared is 1, so 2 times 1 is 2. So 1 is equal to 2 plus some value times 1. Well, what's b? Minus 2 minus 2. So negative 1 is equal to b. So my b value is negative 1. So I could safely assume that y is equal to 2x squared, minus, hello, I want my eraser. Right, there we go. I want my pen, minus 1, x. Well, I could also notice that I could factor out my greatest comonomial and get x times 2x minus 1. Or, if I look at some factors, which is another way to do it, I'm going to have to erase a lot. If I look at some factors, so the factors of 6 are 2 and 3, right? And the factors of 15 are 3 and 5. And this is how most people would probably do it in 8th grade. Factors of this, 4 and 7. I see a connection here. I have my n value, and then here I have my n value, well, 7 is 1 less than 8. 5 is 1 less than 6. And 6 is obviously 2 times 3. So here's my 2n minus 1. And you can't read that because it's on red. That's not a whole lot better. And so there's another way you could derive it. Again, if you don't get it, don't worry. That is an extension.